Okay, so we have this function right here. And the y-intercept, the x-intercept, and then some infinity stuff. Well, again, if we go to the notes right here, here's how we do intercepts. This is from the exam 2 notes. Exam number 2 notes. What do we have there? We have to find an x-intercept, you plug in y0. And to find a y-intercept, you plug in x0, right? So to find intercepts for any equation, you plug in the opposite letter as 0. So coming back to it, how do we find, in this first part, they want us to find the y-intercept. Y-intercept, plug in x0. So I take that little formula they gave me right here. Let me write it up here a little better. P of x is x plus 9 squared times x minus 6. X plus 9 squared times x minus 6, okay? And I'm supposed to plug in x equals 0, because why? Because this is y out here. Remember, function values are y values. So if you plug in 0, 0, and 0, what do you get? So then you get, it's just 81 times minus 6. That's a big number. 486, I think. Yeah. Yeah, because 6 times 8 is 48, and then the 6. So minus 486. So minus 486. And this time they want the point. It's the point. So they want 0 minus 46 with parentheses, because it's an x value and a y value. That's what it technically is. 0 minus 486. Let me go double check that that's what they want in the actual homework, but I'm pretty sure. Yeah, they want the actual point, the actual points, and then they want that, right? That is true. Okay. Okay, so getting back to it, so there's the first one. Next, they want us to come up with the x-intercept. So let's do that. So draw a line in the sand here. And they want the x-intercept. So how do we find an x-intercept? Well, as the notes say down here, you know, to find an x-intercept, plug in y0. So I'm going to do that. I'm going to plug in y0. So I take the equation they gave us, p of x, the formula of the function. What is it? It is x plus 9 squared times x minus 6. And I'm going to plug in y is 0. Where's y? This, remember, is y. Function is y. Okay, so now, and we need to solve for x. So look at that with me for a second. Can you tell me, what can I plug in for x right there to make that part 0? It's got to be -9, doesn't it? -9 plus 9 is 0. And what can you plug into this part to make it 0? Plus 6 minus 6 will be 0. So there's the x values. X can be -9, it'll make the first part 0. X can be +6, it'll make the second part 0. And Now you might wonder, you might say, well, this is kind of strange solving, Mr. Aaron. Why didn't we do this earlier? Why didn't we just look? Well, the reason this works here and doesn't work in many other situations is because these two things are times. That's the crucial issue, right? If two things are multiplied and you make either one of them 0, well, then they're still going to multiply to be 0. If they were added, that would not be the case, right? If I said, hey, I've got x plus 9 squared added, sorry, it's a square, to x minus 6, I wouldn't say, oh yeah, just make that -9. The whole thing is 0. No, just this first part is 0. But the other part's not going to be 0, and they're added. So if the other part's not 0, they're not going to add up to be 0, are they? The whole logic hinges upon the fact that they are multiplied. Do you see that? It's all because they are multiplied. Because they're multiplied, you can make either one 0 and they'll multiply to be 0 because 0 times anything is 0. So what are our two answers then? -9, 0, comma, 6, 0. Why? Because those are the two x values and they both go with a y value of 0. Why? Because they both came from a y0. They both make y0, don't they? So -9, comma 0, comma 6, comma 0. Or you could put the 6, 0 first and then the -9, 0. That doesn't matter. But the zeros need to be in the y slots. So those are the two x-intercepts. So put that in up here. -6, 0, and 9. Or did I do it backwards? Yeah, I did. -9, whatever. You can do it in either order. I'll just put the 6, 0 first, and then the -9, 0. Either way is totally fine. I got them right now, right? Yeah. All right. Got the, so we got the y-intercepts, got the x-intercepts. Now they're doing the x goes to infinity or -infinity thing. So we just literally plug that in. In fact, I can probably just do it right here. Might be the cleanest way. So this is positive infinity. If I plug into this formula, p of x, which is y, remember function values are y values, I'm going to plug in the formula here. I'm going to plug in, let me back and bring that here. Infinity plus 9 squared, infinity minus 6. What's that going to be? Infinity plus 9 is infinity. Infinity minus 6 is infinity. So that's just positive infinity. Y just equals positive infinity. So it's just going to be positive infinity. Now, let's do the other one. Right here, x is going to -infinity. So I'm going to plug in the lower one right here. So now I'm going to say p of x equal, I bring this down here. Y is, again, same formula, x, that's our function, x plus 9 squared times x minus 6. Let's plug in -infinity. Plus 9 squared minus 6. Okay, so what do we got? What is -infinity plus 9? Well, it's -infinity, right? Negative infinity, add 9 is still -infinity. And -infinity minus 6, that's still -infinity. -infinity squared is plus infinity, right? When you square it, negative squared is positive. And then positive times negative is -infinity. So this is -infinity. Like that. Now, again, you might say, Mr. Aaron, it's always the same. It's not. It's not. It's a coincidence. They can make it different. Trust me, you have to actually plug it in and work it out. If there was a shortcut that was valid, I promise I would tell you. I'm not trying to just make it harder and hold out on the shortcut. You really have to do all the work to be sure. Let me double check. Yeah, that's exactly how they do it on that one. And there's, yeah, on this one. So on this one, it really is always going to be that way because they just designed the problem that way. But it doesn't always have to be. Let me get back to the iPad there. So there we go. We finished it up.